All right, welcome to our next section. We've already talked about multiplying and dividing rational exponents, so now let's talk about adding and subtracting. So if you remember, our rational expressions are pretty much the same thing as fractions, only now there's polynomials. So remember, when we were adding and subtracting fractions, we had to have our common denominator. So before we actually start adding and subtracting, let's talk about how to find that common denominator. Ideally, your common denominator is always going to be your least common multiple. So in order to do that for polynomials, you want to factor all the polynomials, and then you're going to take the highest power for each piece that shows up between any of them. So if we look at example number 1, we have 6x squared. 6x squared. Well, I know 6 is really 2 times 3, and then times x times y. Then I can look at 15x squared. Well, 15 is really just 3 times 5 times x squared. And last but not least, if I take 9xy to the 4th, I know 9 is 3 squared times x times y to the 4th. So to find that least common multiple, I'm going to take the highest power for each thing. So for my 2, my highest power is 1. So my least common multiple has a 2. For the 3's, my highest power is 2. So I'm going to have a 3 squared. 5, my highest power is 1, so that's going to be times a 5. My highest power for my x's is squared, so that's times x squared. And then y to the 4th has a higher power than y, so times y to the 4th. Multiply all of that together, and I really have my new least common multiple. So 9 times 5 is 45, times 2 is 90. And then my x squared, y to the 4th. Those are monomials. Let's look at one with actual polynomials then. If I look at y to the 4th, 8y to the 3rd, plus 15y to the 2nd, they all share a y squared. So I'm going to start by pulling that out. Y squared plus 8y plus 15. And then check and see if your trinomial, your y squared plus 8y plus 15, breaks down any further. Well, I know 3 and 5 multiply to 15, and 3 plus 5 is 8. So I know that's x plus 3 and x plus 5. Or sorry, y's. Those should be y's. Try not to mix up your variables like I did. And then I can do the same thing for this other one. Two things that multiply to negative 40, but are going to add to a negative 3. Well, I know 8 times 5 gives me 40. One of them has to be negative, and I want the larger one to be negative because it's a negative 3. So double check. Negative 8 plus 5 is negative 3. We're all set. So to find my least common multiple, I'm going to take the highest power for each part. I have a y squared. So my least common multiple starts with a y squared. I have 1 y plus 3. These are both also supposed to be y's. I have a y plus 5. And I also have a y minus 8. I'm not going to include the other y plus 5 because I already included a y plus 5. And it doesn't have a higher power. So this ends up becoming my least common multiple here. Now remember, our least common multiple is our ideal common denominator. So adding rational exponents. We're going to start by factoring both denominators. we're going to multiply each fraction by what it's missing from the other person's denominator on both the top and the bottom. And then we're going to combine our two tops over a single bottom and factor the top to simplify if we need to. So look at the first example. Looking at just the denominators, we have a 2x and a 5x. This second denominator has a 5 that the first fraction doesn't. So that's what I'm going to multiply on top and bottom. I'm going to multiply both the top and the bottom by a 5. And that gives me 15y over 10x. On the second fraction, the denominator is missing the 2 from the first fraction. So I'm going to multiply this one on both the top and the bottom by a 2. Whoops. Fun fact, 2 times 2 is actually 4. So just like we normally would find a common denominator, we're going to do the same thing. Then add across the top and put it over one bottom. 15y plus 4x over 10x. I can't combine those two terms because they're not like, they don't have the exact same variables. And I can't really factor it because there's nothing to pull out to cross out with the bottom. So that is my final answer. So let's look at example number 2. Factor both of the bottoms. X squared minus 4x plus 3. Well, that factors into x minus 3 and x minus 1. Factor the second bottom. Factors into an x plus 6 and an x minus 1. Now notice that they both have the x minus 1 already. But the first one's missing the x plus 6. So that's what I need to multiply by on both the top and bottom. I'm going to multiply by x minus 6. And now looking at the second one, I have the x minus 1, I have the x plus 6, but I'm missing the x minus 3. So for this one, I'm going to multiply top and bottom by x minus 3. So I end up with 4 times the x minus 6 plus x times the x minus 3 all over, and I'm just going to leave it in its factored form. X minus 6, x minus 1, x minus 3. Now don't start crossing things out yet because we have this pesky little addition sign. Remember, we can only cross things out because they're on the top and the bottom when they're being multiplied. But what I can do is simplify or expand out the top. So let's distribute my 4 and distribute my x. So now I have 4x minus 24 plus x squared minus 3x. All over that same bottom. X minus 6, x minus 1, x minus 3. Combine like terms. X squared plus x minus 24 double check to see if you're going to be able to simplify or if you can factor that top. Is there two things that'll multiply to give you negative 24 but are going to add to get you to 1? Take a second and think about that. Two things that multiply to negative 24, but add to get me to 1. I can't think of anything, which means that cannot be factored, so this is my most simplified final answer. And again, you can leave it without distributing and foiling and all of that crazy nonsense. Leave it with its parentheses and its factored form. So let's do one more example of the adding. Remember, I want to start by factoring out both the bottoms. 4x squared plus 21x plus 5. 4x plus 1x plus 5. 4 times 5 gives me 20x. With one more x is 21x. Yeah, so that should factor like that. And then for the second one, I can pull out a 3. And then I have 4x plus 1. So both denominators have a 4x plus 1. But the first one's missing the 3 from the second. So I'm going to multiply top and bottom by 3. The second one, the blue denominator, is missing my x plus 5. So I need to multiply top and bottom by x plus 5. So I have 3 times x minus 8 plus 6 times x plus 5 all over, and take all 3 parts. So 3 times 4x plus 1 times x plus 5. Now remember, I can't cross anything out yet because I can only cross off when everything's being multiplied together. So let's distribute and simplify. 3x minus 24 plus 6x plus 30. Bring over my denominator. And then combine our like terms. So 3x plus 6x gives me 9x. Negative 24 plus 30 gives me a positive 6 over 3 times 4x plus 1 times x plus 5. Now this one can still simplify on the top. I can still factor that top. Greatest common factor of 9 and 6 is 3, which would leave me 3x plus 2. Now I have a 3 on the top and the bottom that are both being multiplied by everything else. And I can cancel those out. So final answer, 3x plus 2 over 4x plus 1 times x plus 5. Now subtracting is going to be exactly the same, only instead of adding the 2 things on top when we're done, we're going to subtract the 2 things on top. So if I look at example number 1, this bottom has a 7, first bottom has a 7, second bottom doesn't, so multiply both top and bottom by 7. Second bottom has a 3, first one doesn't, multiply both by 3. So I have 18 minus 14c all over 21y. Boom. Same thing, only now we're subtracting. Let's look at number 2. Factor both the bottoms. So I need 2 things that multiply to 12, but add to 7. How about 3 and 4? And then for the second one, 2 things that multiply to 2, but add to 9. Let's not do example 2, because I'm pretty sure I have a typo in there. So let's jump to example number 3. Again, factor top and bottom. X and x multiplies to a -6, but adds to a -1. How about a -3 and a +2? And over here, 5x plus 10, I can pull a 5 out of that. And that gives me an x plus 2. Now notice, they both have an x plus 2, so I don't have to do anything with that. But the first one's missing a 5, so let's multiply top and bottom by 5. And the second one is missing the x minus 3. Let's multiply top and bottom by x minus 3. So I have 5 times x minus 1 minus 4 times x minus 3 all over my new common denominator. 5 x minus 3 x plus 2. Distribute and combine your like terms. 5 times x is 5x. 5 times a -1 is -5. -4 times x is -4x. -4 times -3 is a +12. Notice when I distributed that 4, I took the negative with it. All over 5 times x minus 3 times x plus 2. Combine like terms, 5x minus 4x is x. -5 plus 12 is a +7. So I have x plus 7. And I bring over my denominator. 5x plus 2, x minus 3. I can't factor x plus 7, and it doesn't cross off with anything on the bottom. So that is my final answer. All right, hopefully now you know how to multiply and divide from your previous notes. And now you should know how to add and subtract your rational exponents. Don't forget to do your homework assignment, and have a good day.